Hey there guys, Marco here back with another video. So today we're going to be having a look at parallel connections. Now there's quite a difference between parallel and series connections where we've had a look at series connections in the past. Let's have a look at parallel connections today, why they are important and how we're going to use them in our electronic projects. So without any further hesitation, let's get straight into it. So the main difference between parallel and series connections is that series connections are connected end to end, so allowing current to only flow through the one circuit, whereas parallel connections are connected from the same electronic source. So this allows us to divide the electrons between multiple components and therefore divide the current flow. So we'll have a look at a few practical examples of this just now. Okay, so we're going to be using these two batteries, which we are going to be connecting in parallel. Now let's have a look at a parallel circuit. So what are the main characteristics when we connect these batteries in parallel? When we connected them in series, we noticed that the voltage got increased. So we plus the voltage between each other and therefore we got our total voltage. But with parallel connections, our voltage actually remains the same. There is no new positive or negative point. We actually create a common positive and negative point between these two batteries, basically shorting them out to each other. We have our two red wires right here. I'm going to go ahead and connect these to each other like so. And over here, we have our two negative wires, and we're going to be connecting them together like this. Now, we're going to notice that our batteries are connected in a configuration that looks something like this. So these two positive points are connected to each other and the two negative points are connected to each other. Why would you do this if you don't actually gain voltage? So we can have a look at our voltage right here. Actually going to be average between values, 1.586 volts. So why would you do this if you don't actually gain voltage? Now, the key factor why you would connect batteries in parallel is that you actually double its capacity. So where we had a 1.5 volt battery at 100 milliamp hours, if we just use this one, connecting them in parallel now doubled the amp hours. So it's now a 200 milliamp hour battery at 1.5 volts. So this actually increased our capacity, but the voltage remained the same. That's the main difference between parallel and series connections, is that your amp hour is going to double, but your voltage is going to remain the same. So just remember, positive points connected to each other, and therefore you have your parallel connection. Now you can combine parallel and series connections, but that's going to be a video for another day. Next, we're going to have a look at resistors, how we use parallel connections with them and how it affects their characteristics. So as you guys can see here, I have the same test resistors as last time. These are going to be our 330 ohm resistors. So we can go ahead and measure that again. And we're going to see that get around 328 ohms, which correlates nicely to our 330 ohms that we should be getting. Now, what happens if we connect these resistors in parallel? So as you can see here, we have parallel connections between the two. This is what the diagram is going to look like. But you can see here, I have connected them in a parallel manner. And we can go ahead and measure the resistance across the two. And we're going to see what happens there. 164 ohms. Wow. So what we actually did here is we added two 330 ohm resistors to each other, which now allowed the electrons to split. Half of them is going to go this way, half of them is going to go this way. Therefore, essentially reducing resistance of our circuit to half of the resistance, which we find here. So we're going to take 330 ohms and times that by half. If we had three of these resistors connected in parallel, they were the same, we would have times our 330 ohms by a third. Now, this is very important, and I do recommend that you guys study up on this. If you have different resistor values, there is actually a resistor calculator which you can use online, or you can use the equation 1 over R is going to be equal to 1 over R1 plus 1 over R2 plus 1 over R3. But this is a bit more advanced, and I do not recommend knowing this off by heart when you first get started with electronics. We'll have a look at this a bit later in the future when you learned a lot more. Cool, so that's it for resistors. So remember, if you want to get those pesky resistor values that you don't always get in your kits, you can remember you can halve them by adding 2 of them together. So next we're going to be having a look at switches along with these lights that I've connected for you in parallel. So I have these 2 batteries now connected in series, meaning that my positive and my negative end are connected to each other, and we have a new positive and negative end right here. So I'm going to go ahead and power this light bulb, and you can see how bright it shines. Now that's quite a bright light bulb. Okay, now let's have a look at our parallel circuit we have right here. As you can see here, these 2 ends are connected to each other. I just want to make a clear indication of the difference between a parallel and a series connection. You can see series connection, they are connected end to end, whereas with a parallel connection, both ends are connected to each other, so the electrons can split. So let's have a look if I power these, our battery. Over here we can see we get pretty much the same brightness, which is to be expected, but the current draw of these 2 are actually increased. So they are drawing more current now, but they are shining at the same brightness, meaning our battery is going to die a bit faster. When we have our lights connected in series, you're going to notice that our brightness actually gets reduced quite significantly. That's because when we connect our lights in series, we're going to actually increase the voltage required to drive these 2. These are 2 3-volt LEDs, so meaning, or incandescent bulbs, meaning that we will require 6 volts to actually get the same brightness as we did with our parallel connection. Thank you so much for watching, guys. Really hope you understand parallel connections a bit better and know how to use them in your future projects. Don't worry, we're going to go through all of these things a bit more in future videos where we have a look at it in the practice while building our projects. So this is not going to be the last time you see parallel connections. So we're going to be using it quite a lot, and I'm going to be referring back to this video a lot in the future. So thank you so much for watching. Please remember to like and subscribe, and I'll see you guys on our next video.